Guys, welcome to Unit 9, Quiz 1 Study Guide. To begin with, we're going to be rewriting some logarithmic expressions here in exponential form. And I'm going to be going through the even problems because those are the ones you're required to do. You can look at the odd ones with the answer key if you want a little more practice. So to rewrite this in exponential form, we're going to get rid of the log. And we're going to write the 17, but we're going to write it a little bit bigger. And then we're going to switch the 1 and the 0 around so it looks like that. And that's it. That's exponential form. All right, let's go ahead and take a look at number 4. Here's another one. You'll notice that this one doesn't seem to have a little base number right here. When that happens, that means that it's 10. So, writing this in exponential form, I would get rid of the log and I'd write that base number. And then I would switch these two things around. So I put the -1 here and the 110 here. There you go. So that's number 4. Let's go ahead and take a look at number 6. ln of 1 equals 0. That's how we would write log base e of 1 equals 0. So to write it in exponential form, I would get rid of the log. I would write e to the 0 power equals 1. Go ahead and take a look at number 8. Number 8, we're changing the objective here. The objective now is to actually find out what this equals. Okay. So, I can rewrite this as a 4 to the 3rd power. And then we have a property that says when you have log of a number that matches the base like that, then basically these things can, in a way, cancel each other out, and there's your answer. So the answer is 3. Okay. Let's go ahead and take a look at number 10 here. Once again, you'll notice that I can rewrite this 125. I can write that as 5 to the 3rd power. Now I don't like that 5 in the denominator like that though. So we can make it a numerator number if I just make it negative. The exponent, that is. And then once again, these are going to cancel out and my final answer is -3. Number 12, I can make that 9 match this 3 here by making the 9 3 squared. And then all I need to do is change it from radical form into exponent form, where this is the denominator and this is the numerator of a fraction power. Oops, wrote it backwards though. There we go. And once again, these cross off and the answer is 2/3. Take a look at number 14. Whenever we have decimals, we want to write the number, which is 1, and put it over whatever number place it goes up to. It goes up to the thousandths place, so I'm going to put 1 over 1,000. Now you'll notice that my log doesn't have a base. That means it's a base of 10. So I need to get this 1,000 to be a 10, which I can do, because 1,000 is 10 to the 3rd power. I don't like it in the denominator, however, so we can bring it up to the numerator as a -3. And that leaves me with my final answer of -3. Let's go and take a look at number 16. Okay, on this one, it's already set up for us. The answer is 3. We'll take a look at number 18. This one, you could think of this as a 1st power here if you want to, or you could just remember the property, but either way, the answer is 1. Anytime the base matches the number that's there, there's no exponent, it's just 1. anytime you have a logarithm where no matter what this number is here, if this was a 1, the answer would be 0. That's another log property there we're testing. Oh, I just did number 19, though. I didn't want it 19. But the same thing applies here in number 20, since this is 2. Well, actually, it doesn't matter what this number is. Since this is 1, though, the answer will be 0. Anytime that number there in the argument is a 1, the answer will be 0. Logarithms can never have a negative here, so in this case, that would be a no solution. I just did another odd problem again by accident, but the same answer here applies on 22. Can't have a negative number here, so that's no solution. 24, you also can't have a 0 here. You're only allowed to have positive numbers in that spot. And so once again, that's no solution. 26, we have another log property for this. Anytime you have a number being raised to a power and that power is a logarithm with a base that matches this number, these kind of like undo each other, and you're left with just whatever is here, and that in this case it's x. So the answer to this problem is x. 28, this is merely a calculator question. Just want to make sure that you guys know how to use your calculator. So typing ln of 23 into our calculator, we should end up with 3.135. Now the more numbers you give after the decimal, the more precise your answer will be. And for me, I usually just kind of stop at the thousandths place. Now the next thing they want us to do is they want us to rewrite this in exponential form, just to make sure that it works. So the base is e. The answer that I just got would be the power, and that should come out to equal that 23. So that's kind of like what we did in those first few problems of this study guide here. But once again, you can just type this into your calculator, and you should, if you do e to the power of 3.135, it should be really close to 23. It won't be exactly 23, and that's because we rounded this number, but it'll be really close. All right, let's go ahead and take a look at number 30. This is another calculator question. Notice there's no base here, so that means it's 10. And our calculator has a base 10 on it already. So we're just going to type log 3.3 into our calculator, and we get 0.519. And if I wanted to rewrite this in exponential form, it would be 10 to the power of 0.519. And that should be really close to 3.3. Once again, it won't be exactly 3.3 because we're rounding, but it will be close. Let's go ahead and take a look at number 32. On number 32, we're going to use the log properties that we learned in lesson 9.3 to condense these expressions. So first of all, when a log is being multiplied by a number, that number can become an exponent on the arguments. So you could rewrite this one like that, and you could write the other logarithm like this. Second of all, when you have two logs that are being subtracted, you could rewrite them as one logarithm where the arguments are being divided. Whichever one comes first goes on the top, and whichever one comes second goes on the bottom. And that will be our final answer there. Okay, 34 starts off the same as 32, where if a log is being multiplied by a number, that can become a power of your argument. So we have log a to the fourth plus log b to the second. Now since these logs are being added, we have another log property that says that you could write that as one logarithm where the arguments are being multiplied together. Now we're going to do the same thing as 32 and 34, but now we're working backwards. We want to split these things apart, break it apart, or expand it. Now, on this particular problem, we have a square root, and we're going to rewrite this as an exponent instead. A square root, you could think of that as a 2 here and a first power here, and so that's a 1/2 power. The next thing we're going to want to do is distribute that half power to each number inside of here. Now that we've done that, when you have an argument with numbers or expressions that are being multiplied, you could write each one of those in their own logarithm. And they would all be being added together. Next, anytime your argument has a power, that power can be rewritten as a multiplier of the log. Finally, we typically won't, the test that I'm giving you will not write it as 1/2 times log. Instead, it will write this as log over 2. Same thing here. So that's what the answer would look like on the actual test or quiz. Let's go ahead and take a look at 38. For this one, we're going to start by distributing this power in there to simplify it a little bit. Now, one of our log properties says that if your argument ever has a fraction inside of it, you can rewrite that as 2 logarithms that are being subtracted, where the top part of the fraction comes first and the bottom part of the fraction comes second. And then once again, we can apply the other rule that we've used numerous times today, where if your argument has a power, you can rewrite it as a multiplier of your log. And there it is. All right. Now, we've done log problems kind of like this before, but the problem is that with this one, when we were doing log problems like this before, I can't remember which numbers they were in the study guide now, but we were able to rewrite this as a power of 7, but there's no way that you can rewrite 6 as a power of 7. And so whenever you can't rewrite it as a power of 7, then we're going to have to use our calculators to do it. But even then, we're going to have to help our calculators out a little bit, because our calculators only have base 10 or base e. So what we're going to have to do is we're going to have to do change of base first of all. The change of base formula tells me that I can rewrite that expression as 2 logs that are being divided, where the first log is logging this number, and the one on the bottom is logging this number. And then from there, now that I've rewritten this as an expression with logs that are in base 10, now I can punch that into my calculator to get an answer for this expression. And I end up with 0.921. All right, number 42. Let f of x equal this expression here. Find f of 5. So my goal here is to plug 5 in and to simplify. So let's work on the parentheses first. This is 25 plus 25 plus 10, which is 60. Next, we're going to take care of this by doing change of base on it and using our calculator. There is, after all, no way I can rewrite this as a power of 3, so I can't do it mentally. So I have to do it on a calculator. But to do it on my calculator, I need to change it into a base of 10 using my change of base formula. So let's punch that into our calculator and see what we get. We have log 60 being divided by log 3, and I'm getting 3.6. 727. From there, you're just going to follow your order of operations. We have multiplication is going to come first, so I'm just going to multiply that by -2. And then I'm going to subtract 3 after that. And I end up with -10.454 is my final answer there. And that will do it for our study guide. So hopefully that was helpful, and we'll see you guys for our quiz on next class. Have a good one.